I'm Jim Hazelwood with Revere Control Systems in Birmingham, Alabama. I've been asked to talk to you today about arc flash hazards. The reason we're going to be talking about arc flash hazards is to see how Revere Control Systems can help our customers to fully understand the hazards involved with arc flash. So let's talk about what is an electrical arc flash. The NFPA 70E, which is the Bible for arc flash studies, says an arc flash hazard is a dangerous condition associated with release of energy caused by an electric arc. As you can see from the picture, that is not something that we want to be involved with. So how can we help our customers in order to mitigate or prevent these hazards from occurring? Arc flash faults produce dangerous and potentially fatal levels of pressure, excessive sound waves, toxic gases, heat, and ultraviolet radiation. Also, you have flying shrapnel. It is not a good situation, and we want to prevent this from ever happening at any of our customers' facilities. So let's talk about the two types of major electrical faults. The first one most people are familiar with is the bolted fault. That is what most people call the short circuit, where you have low impedance and you have high current. Typically, this is what will trip the breaker, blow the fuse. There's no additional damage to the equipment, relatively low safety risk. What I want to talk to you about is what's called an arcing fault. This is something that's been around for some time. However, people didn't usually refer to it as an arc flash. It's an incident where you have high impedance, typically air, which results in lower current, which using Ohm's law, you have a higher potentially energy level because of time for the upstream breaker to go ahead and open. It can persist longer and propagate from line to line, from phase to phase, and it will have a high release of energy. Very destructive and dangerous. So how extensive is the problem? Does this happen very often? As you can see here, there are up to 2,000 workers are admitted annually to burn centers. Not only that, a single serious injury can approach $10 million. So something that happens fairly often, and it's very, very expensive. What causes these arc flashes? Typically it's us. Typically it's human error. It's a drop tool, pulling conductor, racking breaker. That's typically 80% of the incident. Now there's other things that have caused arc flashes: loose connections, frayed insulation, contaminants, rodents, those type of situations. But typically it's caused by us working on the equipment. Here is an example of an arc flash incident. This gentleman was not working on the equipment. Actually, dust came down and shorted out the resistor bank, which caused this arc flash incident. This one was caused by electricians pulling wire. Since we have these arc flash incidences, there's now regulatory agencies and standards that handle this type of safety. The first one, of course, is OSHA. OSHA considers the NFPA standard, and it will cite using requirements of the NFPA. Now, if you look at the National Electrical Code, you'll see that it mentions that dwellings that are likely to require examination, adjustment, servicing, or maintenance while energized shall be field marked to warn personnel of potential electric arc flash hazards. And that, in turn, goes to the NFPA 70E, which indicate equipment shall be field marked with label containing the available instant energy or required level of PPE. And this just reiterates that same piece of information. OSHA enforces arc flash safety regulations in the United States. OSHA considers arc flash to be a recognized hazard, and OSHA will fine. Now, there's a 6-point plan for OSHA compliance. Facilities must provide, be able to demonstrate a safety program, have calculations for the degree of arc flash hazard, have personal protective equipment for their workers, train their workers, which in order to be qualified, the worker needs to be trained or retrained every 3 years per the 70E. Have appropriate tools for safe working, and also have warning labels on equipment. These labels are provided by the equipment owners, not by the manufacturers. And here's a listing of various regulation references I like to provide in case there's any doubt as far as what requirements are necessary. Now, how do we measure arc flash? Well, arc flash is the amount of energy impressed on the surface a certain distance from the source generated during an electric arc event. All right. Well, let's look at it another way. 1 calorie per centimeter squared equals the exposure on the tip of a finger by a cigarette lighter in 1 second. I can understand that. So now you can extrapolate that out to an exposure energy of greater than 1.2 calories will cause a second-degree burn. And that is precisely what we're trying to prevent, second-degree burns. Here is the hazard risk categories. The hazard risk categories go from 0 to 4, 4 being the maximum calorie content that you could actually work on. Anything above a 40 calorie can only be worked on de-energized. Obviously, our goal is to have a hazard risk category of 0, which is 1.2 calories or less. Again, not to have a second-degree burn. Category 1 goes up to 4 calories, which requires a different level of personal protective equipment. Category 2 goes up to 8 calories, again, additional PPE. Category 3 and 4 are the same ways. As you can see, goal number 2 is to get to Category 2. The reason being, once you get to Category 3 and 4, you're in more or less the moon suit, which are very, very difficult to work in. As you can see from above, a typical 100 amp 3-phase 480 volt industrial circuit that faults can deliver 10 to 15,000 amps until the breaker opens. This produces an instant energy of about 12 calories at 1 foot. And you notice down below that 5 calories can ignite non-FR clothing. Here's a couple of examples of personal protective equipment. Over to the left is a typical Category 3 or Category 4 suit. Happen to have the hood. Over to the right, that's a Category 2. You can see that you have the face mask, the balaclava, and at least a Category 8 suit. The analysis process, this is done in order to fully understand what the arc flash hazard is. The calculations have to be done to fully understand what the hazards are. We won't go very deep into this, just to indicate typically systems greater than 240 volts and fed from 125 kVA transformers and up are required to be studied and documented. Here's an example of a single line. Over to the left, you'll note that there's a PPE Category 3. Over to the right, you'll notice that is PPE Category 0. These are the same circuits. However, due to mitigation, the fuse was changed out in order to lower this category rating. So sometimes as easy as changing fuses can decrease the rating for the customer. This happens to be the time current coordination curve for those fuses. Let's talk about the importance of hazard warning labels. Again, that is a requirement. It falls under the failure to adequately warn. These labels must be ANSI standard, and OSHA will cite based upon these labeling standards. Shown below is the labeling requirement. As you can see, we have switchboards, panel boards, MCCs. Again, please note the labeling is the responsibility of the employer, not the manufacturer. Here are some examples of some labels that you may see out in the field. These labels are not compliant. If you do see these labels, that installation is not compliant with an NFPA 70E. Labels applied prior to September 30th of 2011 are acceptable if they contain the available instant energy or the required level of PPE. Here are compliant labels. As you can see that they have the PPE category level shown. We have level 0, 1, 4, and dangerous. And you'll also notice that the flash hazard itself and caloric content is shown from 0.43 on category 0 all the way up to 787 calories for the dangerous. Please note that these need to be refreshed every 5 years or unless major changes have been done to the process equipment. Besides PPE, arc flash rated tools are also required. Listed below are some of these products that no longer are you able to take your 3M electrical tape and insulate a screwdriver. That does not meet the standards. Here is an example of Revere's Arc Flash Services brochure. At the bottom of the page is the URL that you can extract that information from. We're always willing to help out in any way we can. Thank you very much, and feel free to contact us with any questions you have, and hopefully we can work together on keeping our customers safe. Thank you.